G'day there, Level 2 Physics. We've come outside to do some practical work here. As you can see, I'm just in the process of attaching the slinky spring to the cabbage tree. We're going to do some work on wave reflection. And so what we're going to do is have a look at what happens when waves reflect. So I've attached this slinky spring to this cabbage tree, which is like a fixed end. I'm going to send a wave. I'm going to send an uppy wave along the slinky spring, and I want you to observe what the reflected pulse looks like. Check this out. Can you see that spring alright? Here we go. Let's have a try. This time I'm going to send a down pulse that way. I want you to watch what happens as it reflects off that tree. Ready? Ooh, do you see what happens? Do you see how it flips upside down as it reflects off the cabbage tree? It's exactly the same as the incident pulse, except that it's inverted. It's flipped the other way up. And the cameraman comes over here. We're going to try the same with a lefty-righty pulse. Check this out. Looking down the wave that way. Check this out. Bit of a lefty-righty pulse. See how it flips the opposite way up as it reflects off the fixed end? This is no laughing matter. That reflected pulse is inverted. It's the opposite way up from the incident pulse. Now, we're going to disconnect off the cabbage tree, and we're going to go and have a look what happens if it's a free end, a disconnected end. Check this out. You can stop recording on number. Okay, so this time we're going to check out what happens when we get a reflection off a free end of a medium. Look, like that one down there, the disconnected end of this spring. I'm going to send a lefty-righty wave from my perspective down this spring. I want you to check out what happens as it reflects off that free end. Look. Do you see how that's totally different to what happened last time? Look, I'm going to do another one. I'm going to do the other way this time. Check it out. Watch what the reflected pulse looks like. Wow! Did you see how the reflected pulse, this time, it was not inverted. This time, it had the same orientation as the incident pulse. In both cases, same wave speed, same wavelength. When it reflected off the fixed end, last time, it was inverted, but this time when it reflected off the free end, it had the same orientation. This is how we draw diagrams of those waves. Look, we've got our little wave pulse going towards the end of the medium like that, and those little dashed lines, those little hairs there, they represent a fixed end. That's the fixed end just there. So what does our reflected pulse look like? That's our incident pulse. Let's have a go at drawing the reflected pulse. And what we're aiming for when we draw that reflected pulse is we're trying to draw exactly the same wave, just the opposite way up. It's going to be inverted. It's going to be travelling the opposite direction because it's reflected. So same speed because it's in the same medium, but going the opposite direction. Incident pulse, reflected pulse. Let's put those labels on there. Okay, so this is what our incident pulse, reflected pulse diagram looks like then. Got the incident pulse going in that way, reflected pulse, same speed, opposite direction. Same wavelength in both cases, but the displacement, the direction that the medium is displaced, that's the opposite on the reflected pulse compared to the incident one. Okay, so what about a reflected pulse from a free end? A free end, what's a free end? How can that be? Because we've got to pull this string tight, right? But allow it to be free to move at the same time. And so the way we think about that is the rod and the ring. The ring is able to slide freely up and down on the rod, but the rod keeps it under tension, keeps it pulled tight. And so the medium can move up and down freely at this end, up and down as much as it likes, but it can't pull backwards or forwards at all. It's held in a constant position. And so here goes our incident pulse going in towards that free end. Let's have a look at what our reflected pulse might look like in this case. Cool, so here goes our reflected pulse then. We've got the reflected pulse coming away from that free end exactly the same way up as it was when it was an incident pulse. The only thing that's changed about it is the direction it's travelling. Look, it's got the same speed, opposite direction, same wavelength, same orientation, and so long as no energy has been lost from the system, that amplitude should stay the same as well, because the amplitude is the amount of energy that the wave is carrying.